Right. So just right. So let's start with a quick recap of the concept of components that we discussed in the last lecture and how it is related to trigonometry in 4 quadrants. Okay, so recap from lecture 3. So first we saw the component representation of a vector. So that was the first thing we saw. And in that we saw that a vector can be represented by an equation like this. Some number into I cap plus some number into j cap, where ax and ay are scalar quantities and they are components of the vector A, the x component and the y component. That is why sometimes they are also called Cartesian components, because they are according to the Cartesian coordinate frame system. Okay. So now the main thing we saw is in terms of application is how to convert components into geometry, that is magnitude and direction, or vice versa. Given that I know the magnitude and direction of the vector, how to convert that into components. So quick review of that concept. That is the main thing we are going to apply in the worksheet problems that we will be discussing. So for example, if I draw a vector right from the origin, most proper sense like this, and then I drop this perpendicular here, and I drop this perpendicular here. Okay, so these quantities which I'm next showing, the projection of this vector or the shadow it casts along the x-axis, and the projection of this vector on the y-axis or the shadow it casts on the y-axis, they are called the components. Okay. So in proper vector form, it is the scalar quantity x into I cap, because it has a direction along positive I cap. Is this quantity ay into j cap, and the sum of these two is becoming the vector E, where this is the magnitude. So the first thing is we can find out the components from magnitude and direction by using this formula, E cos theta, and Ay is E sin theta. Okay. Or conversely, if I know Ax and Ay, from that I can find the magnitude. It is square root of Ax square plus Ay square, and the angle is such that tan theta is equal to Ay by Ax. Okay. So let us look at a quick recap of this concept over here. So I just wanted to work out this quick example problem. We will come to the worksheet and there also we'll be using these things, but first just wanted to quickly work this as an example problem. So I'm giving you 3 vectors in terms of their geometry. So vector E is like this. Makes an angle of 45 degrees. The x-axis and its magnitude is 10. Now vector B, I'm showing in a slightly different manner. The vector B is now like this. And the vector B has a magnitude of, let us say, 15 units, but this angle here, this is 53 degrees. Okay. And I'm showing you another vector, vector C, which is now, let us say, like this. This is my vector C, and that again has a magnitude of, let us say, 12 units, and this angle over here is 60 degrees. So taking these axes as our x and y axis, we have to find, or we have to express A, B and C in component form. So just try this out, people. we call I cap, J cap notation. So that's the first exercise for today as a revision thing. Let's understand, or let's recalculate for these vectors how to express them in component form. So you can see that here basically I'm interested in the application of these things. The magnitude of the vector is given to you in the direction, and there is enough information in the direction so that you know what theta is, the angle with the x-axis. So now you have to just figure out the components and express it in this form, something into I cap plus something in j into j cap. That is called the component notation. So just try this out, and if you can just send me your answers on the chat. Yeah, so anybody got the answer for the first part? Yeah, I think I have. Correct. Vaishnavi, your answer is correct for the first part. So for E, it is fairly obvious. For E, you can see the magnitude of the vector is 10, and the angle it is making with the x-axis is 45 degrees. All you have to do is use the formula now. So Ex is E cos theta become 10 by root 2, or you can further write this as 5 root 2, or you can approximately write it as 7, very approximately 1.4 if you take this as. And Ey is E sin theta, so that will also become 10 by root 2 or 5 root 2 or approximately 7. So the vector E becomes 5 root 2 I cap plus 5 root 2 j cap. So this we didn't have to do any reconstruction of the diagram because it was fairly obvious. But if you want to understand this in proper detail why the angle is 45, you have to actually redraw the vector from the origin. So in the case of the vector E, you just pick up that vector from there, the way I've drawn it, and instead of it being here, you push it here, so that the vector is the same, but it's starting from the origin. So this is what your vector E looks like. Its magnitude is 10, and this angle is 45 degrees. Okay. Hence the working like this. Now apply the same principle to the vectors B and C, but now you'll see that they don't lie in the first quadrant. Do the same thing that I've done over here, but for the vectors B and C next, and you will see that the vector B doesn't lie in the first quadrant. Similarly, the vector C doesn't lie in the first quadrant. So the angle becomes a little bit, more tricky in that case, and you have to use the ESTC rule and the formula that we developed for trigonometry in 4 quadrants to work out which one is negative, which one is positive. Yeah, so Ishita and Likit, you have also got this correct. Okay, so now try out the second question, all of you. I mean the second part, B and C. So the main thing is, can you tell me what is the angle for the vector B? What angle it is making with the x-axis, or which quadrant it is lying in actually? I've drawn it in the fourth quadrant, but it's actually its direction is not such that it's lying in the fourth quadrant. So this is where this gets a little tricky. So what you have to understand is here, okay, this vector B's direction is actually along this line. This is its line of action. Correct? Yes, correct. Just got a message, and that was correct. Yeah, Vaishnavi, your answer is correct. Good. So you can see that this is the angle actually, that is theta for B, because B's direction is along this direction. This is the direction of B. So with respect to the positive x-axis, the angle for B is in fact equal to this angle, which is 127 degrees, or 180 minus 50. So let me re-illustrate this point over here with a new diagram. Okay, so this particular vector that was given to you, that is here like this, something like this. Where this angle is 53, and this was the vector B. Now what we want to do next is we want to redraw this vector from the origin so that we understand the angle more carefully. We just pick this vector up and place it here. So when we do that, when we exactly place this vector from here to here now, without changing the vector, so it becomes like this. It becomes like this. The exact same vector, but now placed at the origin. So you realize that here this is 53, so this angle is 53. So here this angle becomes 53 degrees. So what is the angle with respect to the x-axis? It is this one. So this is my theta, and that is becoming 180 minus 53, or 127 degrees. So now, because theta is 127, you can see it is in quadrant 2. So I have to use the formula that cos theta is minus of cos 180 minus theta, and sin theta is my positive of sin 180 minus theta. When you substitute this, you will see that this is becoming minus of cos 53, which further is how much? It is minus of 4 by 5, and this is becoming positive of sin, minus of 3 by 5, and 53 is, and this one is actually positive of 4 by 5. Let's make a quick correction here. So this one is actually minus of 3 by 5. Okay. So this thing you know from the 3, 4, 5 triangle trick that I have told you. So this becomes the proper value of cos theta and sin theta. And of course the magnitude of B I had given as, what was it, 15? Okay. So theta is this, and the magnitude of B is 15. So again the x component, which is B cos theta, will this time become 15 into minus 3 by 5. That is minus 9. And the y component is 15 into 4 by 5. It is in fact plus 12. Okay. So the vector B itself becomes this minus 9 I cap plus 12 j cap. So this is the proper way of solving the question using the notation and everything correctly. There are any number of shortcuts that you can use eventually, but initially just understand the whole process properly first. Okay, now just make sure that you understand all the steps. Ask me if there's any doubt, and then let's apply the same process to the vector C. Yes, Ishika, your answer for vector C is correct. Oh, wait. Just be careful of the sign, Ishika. Vector C, yeah, correct. Both are negative, na? X and Y, that's correct. Vector C is lying in the third quadrant, you realize. That's correct. Okay, so let's quickly work this out. So you'll realize that the way the question had given you vector C, it was somewhere over here like this. Magnitude is 12 and this angle was 60. But now when you redraw it at the origin, you will see that when you pick up that vector and place it over here, it's like this. So this angle is 60. Same you understand as this angle 60. So that angle is 60. Okay. So now what is the angle theta for it? The angle theta for it is in fact this whole angle. That's why it's in the third quadrant. So theta is actually 180 plus 60, which is 240 degrees. Okay. So that's why my cos theta will become minus cos 60 because it's 180 plus. Okay, so this is in quadrant 3. We use the formula that cos theta is minus of cos theta minus 180 and sin theta is minus of sin theta minus 180. These formulae that when we use over here, so my cos theta will become actually minus half and sin theta will be similarly minus of sin 60. So it will become minus of root 3 by 2. Okay. So this is correct, this is clear. Okay. And of course the magnitude of C is given to you as 12. So that's it. Now we are all set. So C's x component is becoming C cos theta, which will become minus of 6, and C's y component. So it's in third quadrant, you can see, so both the components are negative. Okay, so the vector C itself, when we express it, will become minus 6 I cap minus 6 root 3 j cap. So this is what we mean by the component notation for the vector C, or the vector C written in I cap j cap form. Okay, so this is one thing. So this is one type of situation that you should be well practiced in. Okay. And by the time you complete worksheet 3, you will get enough practice in it. Even today's worksheet, which I'll be giving, it will have a number of applications where you have to learn, you have to know how to do this thing. Okay. This process is actually called resolution of a vector into components. Now what we have done over here, this is called resolution of a vector, in this case vector C, into its components. In this case, it is the xy components. So cx and cy, that thing. So if you hear the term resolution, you understand what it means. Okay. Now let's look at an example of the other type also, where is the reverse thing. The vector is given in component form. Okay. So the vector, suppose, is given like this. It is let's say minus root 3 I cap plus j cap. Now we have to find the magnitude of the vector A, and we have to find the angle with respect to the positive x-axis. So this is just the reverse of what we did in the previous question. There the magnitude and angle were given in the question, directly or indirectly, whatever, and we have to find the components. Here now the vector is given in component form and we have to find the magnitude and direction. Just quickly tell me this correctly. How much is the value of theta and how much is mod A? Okay, so here you can see magnitude of the vector should be given by this formula, root of x component square plus y component square. So that you can see when you substitute it's 2. But just to be precise, it is actually minus root 3 but whole square. So it becomes 3 only plus 1 whole square. So it becomes, okay, so that's how it becomes 2. So generally when we write, okay, so mod A is to correct. Okay, now what about theta? So for that, we have the formula tan theta is Ay by Ax. So that is minus 1 by root 3. Now remember, if tan theta is negative, it could be in quadrant 2 or it could be in quadrant 4 because we have the ASTC rule. So tan is positive in first and third quadrant. So if tan theta is a negative quantity, in general it could be in second quadrant or it could be in fourth quadrant. But now we have to select which one of the two it is. So now you can see that the x component is negative, whereas the y component is positive. That means it is in which quadrant? It is in quadrant 2 and not in quadrant 4. So that means this is a correct option because the x component of the vector you can see is negative and the y component you can see is positive. If you just visualize the vector, you can see it's looking like this. This is how the vector is looking with respect to some standard coordinate frame. Okay, so that's how we understand that it's in quadrant 2. So in quadrant 2, you can see that for quadrant 2, you can see that tan 30 degrees is 1 by root 3. Therefore, tan of 180 minus 30, that's the formula for quadrant 2, will be minus tan 30, or tan of 150 degrees should be minus 1 by root 3. Okay. So now you compare this concept or this value with this thing that we got. Tan theta was minus 1 by root 3, and in second quadrant you know that tan 150 becomes minus tan 30 or minus 1 by root 3. So that means what is my theta from there? It is 150 degrees. Okay. So this becomes the solution for the angle, which is quite critical over here. So this sort of thing we should be able to do without any difficulty. That's the main thing. Yes, Vaishnavi, you got the correct answer. Why it is not quadrant 4? No? You see, quadrant 4 होता तो क्या होना चाहिए था? Suppose Ax was positive and Ay was negative. Then the vector would have looked like this. Ax is like this, positive, and Ay is like this. So you can see it is in quadrant 4. This is the vector. So this would have been the angle theta, this whole thing. Okay. But quadrant 2, it looks like this. This is quadrant 2, this one is quadrant 4. Now here you can see which is the case. Ax is negative and ay is positive. So it is quadrant 2 and it is not quadrant 4. Okay. And similarly, now you can see tan theta is minus 1 by root 3 and theta is in in second quadrant. So in second quadrant, which formula we use? We use the formula that tan theta is tan of 180 minus theta. Minus tan of 180 minus theta. So now tan 30 is 1 by root 3. So how much will be minus 1 by root 3? It will be tan of 180 minus theta. Okay. So we are using the quadrant 2 formula for tan. Quadrant 2 formula for tan is this one, that tan of theta is minus of tan 180 minus theta. So this thing here should be 30 degrees. Understanding my point? Because that's 1 by root 3. Na? So this thing should become how much? 150 degrees. Theta should become 150. If 180 minus theta is 30, that means theta itself is how much? Is 150. Okay, people. So hope this is clear. Okay. So we'll be seeing the application of this in number of questions also we are doing next. So that was about the conversion of components into angle, etc. So component notation itself. Then the next thing we had seen is component algebra. Okay. So that was pretty simple. If you are doing the operation A plus B, for example, it just becomes the sum of the x components into the common factor y cap plus the sum of the y components into the common factor j cap. Okay. Similarly, if I am doing the operation A minus B, it just becomes the difference of the x components plus the difference of the y components into j cap, like this. Okay. So accordingly, you can also see that for example, if I have A plus B plus C, the sum of 3 vectors. Okay. Just do a double addition. First add A plus B, so you'll get this, and to that add C, so you will finally get Ax plus Bx plus Cx into I cap plus Ay plus By plus Cy into j cap. Similarly, if I had something a little bit more hybrid, like I had A plus B but minus of C, then here there would be a minus sign, here there would be a minus sign. Like that. Okay, so this is how we accomplish the component algebra. Okay, so let's see a quick question. So I have the vector E, which is, let's say, 2i cap plus j cap. I have a vector B, which is I cap minus j cap. Now I have a vector C, which is minus 3i cap plus 2j cap. Now I say that find A plus B plus C. Okay. And its magnitude. And then on the other hand, I say find A plus B minus C and its magnitude. So let's just quickly work these two out. Just apply the steps expressed, or the method expressed above in the component algebra method. Okay, so let's work out A plus B plus C. I'll just verify your answer, Vaishnavi. So A plus B plus C is nothing but A's x component, which is 2, plus B's x component, which is 1, plus C's x component, which is in fact minus 3. This is where we have to make sure that when we are putting the components, they are with the algebraic sign. Whole thing into I cap, which is 0 into I cap, plus now A's y component is how much? 1. B's y component is how much? Minus 1. And C's y component is how much? Plus 2. And now just work out the algebra. So 2 plus 1 minus 3 is giving you 0. But other side you're getting 1 minus 1 plus 2. So that is 2. In this, okay. So as you can see, this is becoming 2j cap. That 0 doesn't matter. You can just write it as this. So this is the vector. And because it has only one component, its magnitude is just that component. So magnitude of A plus B plus C is just 2. Because it's square root of x square plus y square. Now x is 0 and y is 2. Like that. Correct. Ishita, your answer is correct. Okay. For both the parts. Now similarly, let's work out the second part. So A plus B minus C. This is what I want to calculate now. So I have to do A is x component. So go back here. So 2, 1 and minus 3 are the x components. So 2 plus 1, okay, minus of minus 3. So there was Ax plus Bx minus Cx. This thing into I can. So Ax itself is 2, Ay itself is 1, but Bx is 1 and Cx is how much? Minus 3. So this becomes this. Similarly, the y components now are 1 minus 1 and 2. So 1 plus of minus 1 minus of 2. So this is my Ay plus By minus Cy. So as you can see, it is becoming 6i cap minus 2j cap. So this is the answer to my second part. This is the vector A plus B minus C in vector form. And now we have to express its magnitude. So mod of A plus B minus C is basically magnitude of this vector, 6x component and minus 2y component. So as you know, that mod just becomes square root of x square plus y square. I'm not bringing in the minus sign here because it's squared, so it really doesn't matter. So 36 plus 4. So square root of 40, which you can write as 2 root 10 or approximately 2 into 3.2, whatever, but this becomes a magnitude. So very simple. This is all just formula based stuff, but the thing is we have to just know how to do it efficiently so that we can incorporate it in longer questions. Okay, so these are the operations that we learned to do in the last lecture. So let's now start applying these to the worksheet problems. Alright, so if you can just turn to your worksheet in front now. If you have the worksheet in front of you, it will help. So some of the questions I'm just going to give you some hints. It's quite easy. Whereas some are tricky questions, so we'll discuss the full method. So let's come to question 1 and 2. They are related to the same thing. So that's very simple. Vector A and B are given to you, and you have to just find the magnitude and the angle that the resultant make. So these two are given, and then you have to find mod A plus B in the first question, and in the second question for the same one you have to find the angle of the vector A plus B with respect to x-axis. So that is a tan theta formula. So anyway, A was given to you as 2i cap plus 2j cap, I think, and B was given to you as I cap plus 2j cap, if I'm not mistaken. Yes. So then you can see that the vector A plus B, just by adding the components, so 2 plus 1 3i cap plus 2 plus 2 4j cap. So that's it. Now once you know this, you know that this will become 5 square root of 3 square plus 4 square, and this will become such that tan theta is the y component divided by the x component. So that happens for 4 by 3 is, for theta equal to 53. So these become your answers. Okay, similarly question 3. So this you will be able to figure out, no problem. You will be having the whiteboard notes, so don't worry. You can send it from there. Now the next question is just like the question we did a while back. Given some kind of xy frame, arbitrarily a vector has been drawn for you, like this, where the magnitude of this vector is given to you as 10, and this angle is given to you as 30 degrees. And you have to now express the vector in component form and all that. So you'll realize that you have to redraw this vector over here. You have to redraw it here now. To understand properly, that is lying in the second quadrant. So it will have a negative x component. So this angle will become 150 degrees. So this is 30. This magnitude is 10. So you know that cos 150 is minus cos 30. So that is minus root 3 by 2. And similarly, sine 150 is positive of sine 30, so plus half. So using this, now you know the magnitude is 10 and you got sine theta cos theta, so you can find out the components. Okay, so that is your question number 3. Okay. Now I'll come to question 4 and I'll explain what to do. Okay, so in question 4, there are a number of ways of solving this, but from what we have learned so far, there is only one method. You are given the vector A and given the vector B, and you have to find the angle between A and B. Now, in case you haven't worked out this question yet, this is what I'd like you to do. So what you do here is first find theta A, that is the angle of the vector A with respect to x-axis, positive x-axis. Then find theta B, that is the angle of the vector B with respect to the x-axis. So then what you're looking for, the angle of A with respect to B, will just be the difference of these angles per magnitude. Okay, so you'll be able to figure this out quite easily. So just using the method that we discussed in that problem earlier, where we had found out the angle that a particular vector was making with the x-axis, including the quadrant concept and all that from the tan theta formula. So you apply that for the given A and B separately. So I'm just writing out what A and B are given also. So A is given here in the question as, what is it, 12i cap plus 16j cap. Okay. And the vector B is given as minus 8i cap plus 6j cap. So using the method that we used in the problem earlier, in the example problem, you find out these two things. You find out theta A and theta B, and then you substitute that here, so we'll get this. So first tell me what angle the vector A is making with the x-axis and what angle the vector B is making with the positive x-axis. And the moment you answer that question, it will be clear to you what is the angle between A and B. it will become absolutely obvious. Okay. So just complete this problem, people. Right, so Anna, your answer is correct. The final angle will be 90 degrees between A and B. Because you see the individual angles that they are doing will be how much? They will be 53 and 143. Individually, these vectors will be making those kind of angles, 53 and 143. Look at the situation of vector E. Vector E is in kind of this kind of a situation. Because vector E's components are 12 I cap plus 16 j cap. So you can see that the angle it is making is such that tan theta is 16 by 12 or 4 by 3. So that means theta is 53 degrees. Now both the x and y components are positive. So you can see that is lying in the first quadrant. And this angle comes out to be 53 degrees. But if you look at the vector b, now the vector b is such that it is having a negative x component, minus 8, and a positive y component, plus 6. So its x component is negative, its y component is positive. So we know from the beginning that the vector b is lying somewhere over here. Something else. Where, if you drop this perpendicular here, this is minus 8. If you drop this perpendicular here, it is plus 6. So now we are interested in this whole angle. Okay, so that angle we such that tan of theta b is minus 6 by 8 or minus 4 by 3, and it's in second quadrant. Okay, so for second quadrant we use that formula again, that tan of theta v is minus of tan 180 minus theta v is equal to minus 4/3. So that means 180 minus theta is equal to 53. Oh, my mistake. This is 3/4. Just quick correction here, friends. 6/8. So that is 3/4. Okay. So this being 3/4. Okay. So you can see this is actually 37. So that means what is this angle theta? It is 180 minus 37 or 140. So this angle here is 143 degrees. Okay. So finally, which angle we have to calculate? We have to find the angle between A and B. So we have to calculate this angle. So this angle. This is theta U. Okay. That's the angle between A and B. So that angle, let us come by 143 minus 53. That's one. So this is the complete method and solution of this question. So I think question number 4 or whatever. Yes, question number 4. Okay, so just make sure you have this written down and understood, and move on to question number 5. I'll explain. It's quite easy. Right, so people, hope this is clear. So next, question number 5 is again easy question. I'll give you a hint, it should be enough. So question 5 was now like this, that 3 forces, out of that 2 are given. This one is given to you in component form, this one is given to you in component form. This one is unknown, the third force is unknown. But it is also given that when all 3 forces act simultaneously on a particle, the net force on it is a null vector, or the resultant force is 0. So it's like this. So what this means is that the force F3 is negative of the force F1 plus F2. It's negative of this. So that means the magnitude of the force F3. Now remember, magnitude does not include sign. So this minus sign goes away. It is just mod of F1 plus F2. So ultimately, it's a problem of just finding the magnitude of the sum of 2 things. So 2 forces are given to you in component forms. So all you have to do in this is just, you have to add the 2 forces and find the resultant magnitude. Okay, so just make a note of that. And then come to the 6th and 7th question. They are interconnected, the same data for both of them. Alright, so people hope this is clear. Now for question 6 and question 7, this kind of data is given to you. The vector A plus B is given and the vector A minus B is given. Okay. And from that we have to find the magnitude of vector A and we have to find the magnitude of vector B. So it's very simple. You are given the sum and difference of two things. So how do you solve it? Add these two, you will get 2A, or subtract these two, you will get 2B. So this I think was, what was it, 10 I cap or 5 I cap or something like that. Yeah, 10 I cap. And this is 10 root 3 J cap. Okay. So you just think of this as equation 1 and this is equation 2. So next what you do is you do equation 1 plus 2. So what you will get? You will get 2A is equal to 10 I cap plus 10 root 3 J cap. So that means the vector A itself is half of the right hand side, 10 I cap plus 10 root 3 J cap. So that means, that means that the vector A can also be expressed as, take the half inside, distributive property, so 5 I cap plus 5 root 3 J cap. And then from this calculate the magnitude of the vector A. So it will come out to be 10. Square root of 5 square plus 5 root 3 whole square, that will come out to be 10. So like that, okay. Now similarly for B, now what you can do is you can do equation 1 minus equation 2. Or you can take the value of A that you got here and resubstitute it in equation 1 or 2, you get the value of B. So it's just a bit of algebra. It's like with scalars, you could have done something like this. If x plus y is given and x minus y is given, you can find x and y individually. Like that here, now you have to do that with vectors. That's the only difference. So that is the question 6 and 7. Okay. Now we come to one of the more tricky type of intricate kind of questions of this exercise, which is question 8, 9 and 10 combined. Okay, so that we're going to solve. So hope this should be clear without any difficulty. So next, coming to the combination of these questions, question 8, 9 and 10, they are based on the same data. So in that it is given to us that first of all that the vector E has a magnitude of 5. Then the vector C, which is given as A plus 2B, is such that C is perpendicular to A. Okay. And then another thing given to us is that the vector D, which is just the resultant of A and B. Now this is such that the magnitude of the vector D is also equal to 5. So from this now what we have to find out is the magnitude of the vector B, the magnitude of the vector C, and the angle between A and B. So those are the three questions individually, 8, 9, and 10. You have to find out these things. Okay. So again, if you think about it, it is down to a situation where certain things are known to us and certain variables are unknown. So we have to generate the number of equations according to the number of variables which are unknown. So what is known to us here? The magnitude of A is known, the magnitude of B is known, and the angle between A and C is known, because it is given to us that C is perpendicular to E. So it's like these three informations are given to us. Whereas what we have to find out? We have to find out the magnitude of B, to find out the magnitude of C, and we have to find the angle between A and B. So three unknowns. So somehow this information that is given, that has to convert into three equations. Okay. Now, I mean, you might have been used to doing component algebra till now. So first thought might have been, let's try to use component algebra. So we can do by components also, and I'll show you that method. But here I will start by saying that, okay, if you examine the problem, you see that C is the sum of two vectors such that there is a 90-degree angle involved. So if you think geometrically, you can convert this second statement, ये जो दिया हुआ है, C is equal to A plus 2B, you can convert this into a triangle, which is which type of triangle? Right angle. So maybe triangle method is going to be easier, because it's a right angle triangle, so that's an easy triangle to solve. Similarly, this information that is given, D is equal to A plus B. अभी D का magnitude कितना है? A के magnitude के जितना ही है, 5. So again, it is going to be an easy triangle to handle, because it's going to be an isosceles triangle. So maybe using geometrical method might be easier. That's like the first thought that might come to your mind. So let's see what happens when we use geometry. So I'm first going to solve this geometrically. So the geometrical solution is like this, that I have to convert the information that is given to me into geometry. That is, one information that is given to me, let's say point 1, is that the vector C is equal to the sum of the vectors A and twice of B, not B, but twice of B, and C is perpendicular to A, okay, and magnitude of A is 5. This is the first piece of information that is given. Okay, so let's convert that into a diagram now. Okay, so suppose my vector E, just assume, okay, it's not given that it's along the x-axis, but I can take my x-axis wherever I like. So suppose this is my vector E. So I have information about vector A, that is magnitude is 5. And I have some information about C, that it is perpendicular to A. So C का मुझे magnitude नहीं पता, so I don't know how long the vector is in length, but I know that its direction is like this, it's at 90 degrees. Either up or down, we'll have to draw one of the two. So by default, I'm taking this. So I know that the vector C has to be this. I don't know its magnitude, okay, but I know this angle is 90. Now, according to this information, what is the relationship of B over here? In fact, the relationship is between 2B and C. What is C? It is A plus 2B. So just go back to the addition of vectors. If you add A plus B, then this would have been C. Okay, so this is the type of vector triangle that you have. In this triangle, what is happening? This angle is 90. So where is the vector B? Or in this case 2B, it is here. Okay. So when you put this information which I boxed over here into the relationship between A, B and C, you will realize that B has to be a vector which lies over here. In fact, that is 2B. So the vector 2B, it has a magnitude of twice of B, which we don't know. Okay. And it is making some kind of an angle with A, which will be this exterior angle, theta. Or let's say this interior angle is alpha. So theta, which is 180 minus alpha, is unknown. B is unknown. I mean, 2B is unknown, but basically B is unknown. And C is unknown. So in this triangle, we are having 3 unknowns. But we are knowing the base is 5 and we are knowing this angle is 90. So what are the easy equations that we can write over here? We can write the equation that, first of all, from Pythagoras, we can write that 2B ka whole square is equal to C square plus A square. Or in other words, 4B square is equal to C square plus 25. Let us say that is my equation 1. Okay. And another information I have is that this alpha is unknown or theta is unknown. So from this I can see that, for example, cos alpha is based upon hypotenuse. So it is it is A by 2B we can write, and we know that A's magnitude is how much? 5. Okay. Because this is A, A is equal to 5. That's given to me. So I have this additional information that cos alpha is equal to 5 by 2. So I have 2 equations. Now as you can see here itself that we have 3 unknowns, alpha or theta, that's the same thing, and B and C, whereas we have only 2 equations here. We have all 3 variables in the equation. Alpha is also there, B is also there, C is also there. So we need at least one more equation. We need a third equation. So where is that third equation going to come from? It's going to come from the thing we haven't used yet, and that is which thing? The relationship between A, B and D. So just like I've done this, now next thing what I want you to do is draw a vector triangle for the operation D is equal to A plus B. And from that get a third equation, okay, where it is known to you that magnitude of D is the same as the magnitude of A, which is 5. So use this to generate a third equation. Okay. So then use this to generate equation number 3. Equation 1 and 2 I have just shown you how. Okay. So make a reference of this if you like with respect to this diagram. Now think how that other triangle will look. The triangle not involving A, B, and C, but the triangle involving A, B, and D, for which the information I have given you over here. Okay. So how will that triangle look? And from that triangle, try to figure out another equation. And once you got that third equation, you're done, because you will have 3 equations and only 3 variables. So that's it. So hope you're understanding what I'm saying in terms of solving this problem, people. And now just try this out. Okay, so hope you're working on that triangle. So let's illustrate. So all we have to do is pick up the same vector A from above. So that is this. But this time to that we are adding the vector B. So the vector B will be like this in comparison to the above triangle, because इसका magnitude उसका half है, but this angle between A and B is the same. So that is this thing you have to understand. Okay. So this angle is that alpha only, and this angle is that theta only. So the magnitude of A is 5. But now understand, magnitude of B is 1/2 of the magnitude of the vector 2B, and direction is same. That is why if you now compare this diagram with the diagram above, you realize there's no change in the angle between A and 2B with respect to the angle between A and B. But because the magnitude half ho gaya, so when we are adding these two, we are getting a different vector D. Here we were getting the vector C, which was like this. Now we are getting a different vector here, which is D. Okay? So coming back to the lower diagram, detail. So in the lower diagram, now the sum of these two is this vector D. Now for that, I don't have information about the angle, but I have information about this thing, magnitude. That magnitude of D is 5. So this is the vector triangle that we are getting from the operation, that D is equal to E plus B. Okay, so this information we have. So here, now what is the relationship between these? We have, since D is equal to A plus B, we have the relationship that mod of D is, by triangle law, root of A square plus B square plus 2AB cos theta. Now in this, cos theta will become minus of cos 180 minus theta. Okay, because theta is in second quadrant, that is minus of cos alpha. So you can see over here that alpha is 180 minus theta. So in terms of alpha, this will become what? That d is equal to root of a square plus b square minus 2ab cos alpha, because cos theta will be replaced with minus cos alpha. So substitute this here. So we're getting this. Okay. So now substitute. So 5 is equal to root of 5 square plus unknown value b square minus 2 times 5. So that will become 10 into b into cos alpha. So further, in fact, if we square both sides of this equation, it becomes even more convenient. So 5 square is equal to 5 square plus b square minus 10b cos alpha. So you can see that b square minus 10b cos alpha should be equal to 0. So this gives you two possible roots. B is 0, which is not acceptable, because you can see B is a vector which is not a null vector, so it has some magnitude. So this is not going to be an acceptable solution, that B is 0. The other root is going to be that B is going to be equal to 10 cos alpha. So this is the acceptable root. So our third equation becomes this: B is equal to 10 cos alpha. Now you just compare it with the equation 1 and 2 above and come up with the solution. So first of all, I am leaving this for you so that you can compare these two triangles and understand how they are related in a sense, because there we have 2b and here we have b. So the direction of that second red colored vector we are adding is the same, but only in the lower triangle its magnitude is just b, in the upper triangle its magnitude is twice of b. Okay, so that's that, and now just collect the three equations together and solve them, and you'll get your answer. Equation 1 and 2 are here, and equation 3 is coming from this triangle below. Okay, so let's see how we'll solve this. It's quite easy actually. If you look at your second equation, it was cos alpha is 5 by 2b. So the second equation was cos alpha was 5 by 2b. This was my second equation. So just substitute this in the third equation. So your cos alpha goes away and you will get the value of b. So you get b is 10 into 5 by 2 cos alpha. Sorry, 5 by 2b. So you get b square is equal to 25, which in general means that b should be plus minus 5, but here b will just be 5 because it's the magnitude of a vector. So that answers that part. The magnitude of the vector b is also 5. Okay, and then substitute it back. So cos alpha is 5 by 2b, so that's this, so it's half. So alpha is how much? Alpha is 60 degrees, which doesn't still answer the question because we have to find theta. So theta is the angle between A and B. So theta is 180 minus alpha. Theta is 120 degrees, and this is the angle between the vectors A and B. So this is also done. And finally, you also have to find C. So C was coming from that formula that 4b square was c square plus 25. So now in this substitute b. So 4 into 25 is equal to c square plus 25. So from this you will get c as 5 root 3 minus 1. Okay, so the magnitude of the vector c is 5 root 3. So this becomes the complete solution set of this. Okay, now for this, you can also do one thing. You can take a component algebra approach instead of a geometrical approach. Okay. So alternately, what you can do is this. So use all the information given to you. So by that, what you can do is, if this is your xy plane, you can assume that the vector E is lying along the x-axis. The vector V is something unknown. So A, you write as 5 I cap. Then the vector C is supposed to be perpendicular to it. So make use of that information. So vector C is supposed to be perpendicular. So let's take it along the y-axis. So the vector C's magnitude is unknown. So it is just some C j cap. This magnitude is unknown. And vector B, we don't have any information whatsoever about. We'll just write vector B as bx I cap plus by. And now we have other information that C is equal to A plus 2B. So write this down and this will give you some things. Okay. And we have the vector D is equal to A plus P. Okay. And the magnitude of vector D is 5. So write this down in terms of components. So because these are vector equations, by solving the components, you'll be able to generate 3 simultaneous equations or 3 simple equations involving bx, by, and c, these 3 unknowns. Okay, because D's magnitude is given to you. So in terms of these 3, you will have 3 equations. So solve. And once you solve, you got the vector b. You would have got this. So from that, you can find magnitude of b. You can find the angle theta. That's it. That's all. So you can try this approach yourself. It will be a good practice of how to solve problems using component algebra. So that is an alternate approach for solving this question. Okay, now let's come to the next series of questions, which is again comparatively easy. So I will just give you the hint. So questions 11 to 15, so 11 to 14, they are all based on one diagram. And if you just solve the vectors given in the diagram, write them in component form, you will be able to answer everything required. So in this XY system, the vector A is given something like this. Its magnitude is 10, and this angle is 60 degrees. The vector B is kind of like a mirror image of it. You realize, take the y-axis like a plane mirror. It's like a mirror image of it, with its magnitude being the same, and this angle being 60. So also be mindful of the fact that that means this angle is 120. And the vector C is a very simple one. It is along the positive x direction. It doesn't matter where we draw it, but it's a vector along the positive x direction, and its magnitude is 10. And then you have to answer various things, like you have to answer about the vector E plus B. What is the magnitude and direction? The vector E minus B. What is the magnitude and direction? In a later part, you see you have to do operations like E plus B plus C. You have to do operations like E minus B plus C, or E plus B minus C, things like this. So how to do all these operations? So what you do is you express A, B, and C in component form, and then fit the values in each of the things that you're finding. Substitute the values in each of these. So find E, B, and C in component form, and then just substitute. Just to help you out, the vector A I am writing down for you. The others you work out yourself. This will be 5 I cap plus 5 root 3 j cap. Now, similarly, you tell me what should be B and what should be C. Then we can go down and solve all these parts. Okay, so just from this diagram, figure out and tell me what are the vectors B and C in component notation. Okay, so you should be able to figure out that B will become minus 5 I cap plus 5 root 3 j cap, and C will be just 10 I cap. So for example, from this now you can see that the vector E plus B, it is just 10 root 3 j cap. The vector E minus B, it is just 10 I cap. Therefore, you can also see that the vector E minus B minus C will be a null vector, because C is 10 I cap. So from E minus B, if you subtract C, it will be 0, or it will be a null vector. So all these things will help you in solving the questions. Only there is a correction in the answer key in one of the questions. I'll just verify and tell you. So just make a correction in the answer key. Question 11. The correct answer should be C. It's given at the back as B, so that is not correct. Just make a, that's a typing mistake. Instead of B, it should be C. Rest, I think you should be able to figure out this question without any difficulty. And same thing, you should be able to figure out the 15th question also. It's a very simple thing. 15th question, just understand that 12, 5 and 13 are a Pythagorean triplet. So just use the fact that 12, 5 and 13 are a Pythagorean triplet for the 15th question. Okay. So with this, I think you should not have any difficulty with completing this worksheet. And this worksheet is a very important one because it really illustrates to you the various techniques of using both geometry as well as component algebra, and how you can interchange the two, geometry to component, component to geometry, and solve questions very efficiently. Okay. So make sure you work out each and every question of this, and you work it out on paper properly with all the steps and all, such that later when you refer to this at some point of time, you can understand the steps. And as always, if you have any difficulty with any of the steps or any questions, you can always contact me immediately through WhatsApp. You can send me the question, or you can send me a picture or a photo of the working that you've done in your notebook, so that I can even help you out with the steps that you're doing, not just give you the solution, but help you out that way. Okay. So that's about the worksheet discussion, okay, which is a big part of today's lecture. Now the next thing we will see is some additional kind of theorems. So we will now for some time go back to geometrical representation of vectors, and in that we will see some useful special theorems. Like we have the triangle law of addition, like that there are some additional concepts and additional observations and theorems that we can see. So some useful theorems and equations and things. Okay. So the first thing is, just reiterate what we already learned, triangle law of addition, but certain more things that we can get out of this. Okay. Or the sum of two vectors. So some more aspects of this that we can understand. So now I'm going to draw two types of situations where we are using triangle law. One is where the vectors A and B are like this, so they are at an acute angle. Another where the same two vectors are like this, they are at an obtuse angle between each other. So here theta is like this, so it's an acute angle. And the other is where the direction of A and B is such that the angle between them is something greater than 90. It's an obtuse angle. Okay. And in this, when we look at within the diagram, when we look at where the sum of the two vectors lies, this in this case, and it's this in this case. Now, the method of solving for the resultant is the same in both the cases, only the way we substitute theta is different. So we have the formula of the triangle law that the magnitude of the sum or the magnitude of the resultant is given by this formula root of a square plus b square plus 2ab cos theta. But the thing is now, you can see one case is when theta is less than 90 degrees or acute, which is what we have drawn above to the left. So in that case, what actually happens is whenever theta is acute, you can see cos theta is positive, as you know. So if cos theta is positive, then the quantity inside the square root over here, inside the square root, this quantity, it is a square plus b square plus something. What that means about the magnitude of a plus b, it is larger than the hypotenuse of a and b. It's a quantity which is greater than root of a square plus b square. So that's an important additional observation that we can make, that whenever the magnitude of the sum is greater than root of a square plus b square, that means the angle is what kind of angle? It is acute. Okay. Whereas in the second part of the diagram, you can understand why this is happening also. The moment your angle is becoming obtuse like this triangle is getting stretched in such a way that this side is going to become less than the hypotenuse. Here it was more than the hypotenuse. Okay. So if theta is greater than 90 degrees, or it is what we call an obtuse angle, then cos theta, by now you know, is a negative quantity. For example, cos of 120 is minus half, cos of 150 is minus root 3 by 2, cos of 135 is minus 1 by root 2, like that. So now what is happening is, in your expression, inside the square root, you have a square plus b square plus 2ab into a negative quantity. So this quantity actually, 2ab cos theta, is a quantity which is subtracting from a and b. So as a result of that, the resultant of a and b has a magnitude mod a plus b, which actually becomes less than square root of a square plus b square. Okay. Whereas there's also an in-between case for which I have not made the diagram, but that's easy to understand. When theta is exactly 90, neither less nor more, so you have perpendicular vectors, the perpendicular condition, cos theta becomes 0. So that is when your mod of a plus b exactly becomes equal to root of a square plus b square. So this is, you know, a set of inequalities, or you can say it's like a comparison. Compare the resultant with root of a square plus b square. If it comes out to be larger, that means the angle is acute. If it comes out to be lesser, that means the angle is obtuse. So this is something very useful while analyzing questions. Now, when we have those type of questions, when we are doing some back calculation, so the moment we are mindful of this fact that, you know, if we compare the resultant's magnitude with the root of a square plus b square, we are getting some indirect information that the angle is acute or obtuse. So this helps us in solving those type of problems a lot. So that's why this is one of the important points over here. Okay? So just make a note of this, people. Right. Now, another thing you can see within the same formula, it is very important. Also, we have this formula So on the right hand side of this formula, you can see that in which case this whole quantity is maximum, when cos theta has its maximum value. Okay. So you can see here that cos theta, iska maximum value kitna hai? Positive of 1. And that happens in which case? When theta is 0. And iska minimum value kitna hai? With 4 quadrants in mind. Minimum value is not 0, it is in fact minus 1. And that happens when theta is equal to 180 degrees. So you can see that when cos theta is becoming plus 1, this whole square root term is becoming a plus b whole square, the term inside the square root. Whereas when cos theta is minus 1, this term is becoming a minus b whole square. Okay, so you can see over here that therefore mod of a plus b is actually equal to the magnitude of a plus the magnitude of b. Or, if you want to state it better, it is the sum of mod a plus mod b. But this happens when theta is 0, or only in the case when a and b are parallel vectors. So this is something again which is important to understand. Okay? That in which case the magnitude of the sum is equal to the sum of the magnitudes. Like you have a vector 3 and 4 in magnitude when their resultant is 7, when they are parallel, like we've seen before. Okay, similarly, when is the resultant becoming the difference of the two? Okay, it is becoming mod of a minus b, because that quantity inside the square root is a minus b whole square. This is happening. We'll just note this down below so that it doesn't confuse with the part above. So this is the first special case when theta is 0. Okay, and similarly, for the case when theta is 180, mod of a plus b becomes how much? It actually becomes the difference of the two. It becomes e minus b, but because it's a mod, we'll write it with this. It becomes square root of a minus b whole square. Okay. So this happens in which case? It happens when theta is 180, or they are what we call anti-parallel vectors. Okay, and all other cases, it is something in between these two extremes, mod of a plus b and mod of a minus b. So that is why in general we say that there is this kind of an inequality, that the magnitude of the sum, in all cases, it can never exceed this. It can never exceed this. Okay. And it can never become less than this. Okay. So this particular statement, you might have seen in your module also. This is called the triangle inequality because it comes from the triangle law. Okay. So just as an example, if I have magnitude of the vector E is, let us say, 20, and the magnitude of the vector B is, let us say, 15. That means the magnitude of A plus B, even though I don't know the angle right now in between them, but I know the range of values. In no circumstance it can be greater than 35, and no circumstance it can be less than 5. Whatever the angle theta, it has to lie between 5 and 35. If I say that for these two vectors now, the magnitude of A plus B is 2, that means my statement itself is wrong. There's no angle theta for which the magnitude can become 2. Understood the point? So I'm just going to minimize this so that you can work this out. I mean, you can note this down. Also a pet who is clinging to me for some reason. So I'll just Katie. Okay, so this is called the triangle inequality. Okay, people. So hope this part is clear. This is one of the observations that we have from the triangle law and its various applications. Clear? That first of all, you can compare the magnitude of the resultant with root of a square plus b square, or like a hypotenuse term, and that will tell you whether your angle is acute or obtuse. If it is greater than root of a square plus b square, it will tell you that the angle is acute. If it is less, it will tell you that it is obtuse. But greater matlab kitna tak ja sakta hai? What is the maximum it can go to? So the maximum it can go to is in fact a plus b, and less than matlab how much less than it can be? So it can go up to a minimum of a minus b. So this is it. Okay, now next we will see a secondary form of triangle law which is used for calculating the difference of two vectors. Till date, we have used triangle law, or we have used the form of triangle law to find the sum. Now the next thing we'll see is like a second version of triangle law. So you can say it is like a part B for difference of two vectors. Okay. So if you want to find the difference of two vectors, let's say C is A minus B. Given that we know the magnitude of vector A, we know the magnitude of vector B, and we know the angle theta between. These three quantities are known. So in other words, we have, let's say, geometrically we understand that vector A is like this, let's say, vector B is like this, let's say. So you know the lengths of these two lines or these two arrows. This angle is. Okay. So now how we calculate the difference is like this, that we interpret A minus B as the sum of A plus of minus B. In fact, we've done a question earlier based on this from worksheet 1 or 2, 1 and 2, where we had used this. So now we'll understand the formula officially. Okay. So now the question is, what is the vector B? What is the vector minus B? Minus B is nothing but minus 1 multiplied by the vector B. Okay. So in other words, it is a vector of magnitude same as the vector B, but direction opposite. Okay. So going back to my diagram, if this was the vector B, where this angle was theta, now the vector minus B will just become this one. Be a vector like this. It's anti-parallel to this. You can draw it here also like this. So it should have the same length as this one. So this is having the same length as this, but it's having opposite direction. So now this angle here is theta. Alright, so this is the vector minus B generated from the vector B. Whereas my original vector A was this only. We are taking the vector A like this. So now from this we want to generate this operation, the vector C, which is A minus B or A plus of minus B. So how will we proceed with that? So what we have to do now is, instead of adding A and B, we have to add the vector A, but with which one? With this vector minus B. So let's do that geometrically. So you'll see that I'm just drawing A longer for reference. Just imagine this vector is longer. So this is my vector A. Now to this I'm adding this one. So this vector lies over here. This is my vector minus B. which has a magnitude of b, but which now you can see makes an angle with respect to a of how much? This, which is 180 degrees minus theta. Because this angle is theta. This angle is theta. The angle between, so angle between A and the vector minus B is not theta. It is in fact 180 degrees minus. So I'll just minimize this a little so that you can compare it with the above diagram and it becomes clear why that angle is 180 minus theta. That exterior angle is 180 minus theta. Okay, so now back to this, what we are trying to do next is we are trying to find out the vector C. So what is the vector C? It is the sum of A minus B. And the vector C is the sum of A and minus B. So that's what we are trying to do next. So in this diagram, we want to find the vector C, which will be this one. This is a vector C, which is basically E minus B. Because the operation that we've done over here is actually an addition, but it's an addition of the vector E with the vector minus B. So that addition is actually resulting in the difference. That's the second. Okay. So by the triangle law of vector addition, what should be magnitude of the vector C? It should be square root of magnitude of A square plus magnitude of minus B square, because C is actually the sum of A and minus B. So from here you can see I'm using triangle law on this, plus 2 times the magnitude of A into the magnitude of minus B, okay, into cos of the angle between them. So what was the angle between them? It was this, it was 180 minus theta. So cos of 180. So now in this I will use the fact that magnitude of A already we know, we've written it as capital A, but magnitude of minus B is actually the same as the magnitude of B, because they're just opposite vectors but of same magnitude. So that's B. Okay. And I have the formula cos 180 minus theta is minus cos theta. So substituting these 3 things in the formula of triangle law, but this time we are adding in the triangle law, we are adding A and minus B. Instead of A and B, we are adding A and minus B. So automatically it's giving us A minus B. So that's why my vector C, which is basically mod of A minus B, the magnitude of C. So this is becoming square root of A square plus B square minus 2AB cos theta. Okay. So this now becomes my triangle law part B for the difference of the 2 vectors. Okay. This is triangle law for difference of 2 vectors or subtraction of 2 vectors. So this is like the second part of the triangle law that we've learned earlier. The first part was to find A plus B sum, and the second part is to find A minus B difference. So just make a note of this, people. We are almost done. A couple of more things we'll see based on this. And Okay, people, so hope this is clear. Now, one more thing we have to do in this is we have to find out this angle. The angle that the vector C or the difference makes with respect to A and B, with respect to A. So also, for beta, that is the angle of the vector C with respect to the vector E. We can see we can use the similar formula as we have done for tan alpha, but we will have to replace theta with 180 minus theta. So tan beta will become magnitude of minus b sine of the angle between them. So that angle is 180 minus theta divided by magnitude of E plus magnitude of minus b into cos of the same angle. 180 minus theta. Okay. So now in this also you know that cos 180 minus theta is minus cos theta. Whereas sine 180 minus theta is positive of sine theta. And mod of minus b is b only. So using that, get the formula that tan beta is b sine theta upon a minus b cos. So this is the angle formula. And the above is the magnitude formula for triangle of a difference. Okay, so hope this is clear. So just add this to the list of theorems that we have in geometry. And now finally we'll see something very useful, that we can combine these two theorems, the triangle of addition and triangle of subtraction, to get one combined sort of theorem, which is called the parallelogram law. So next we'll see just a minute, I'll refresh the board. Just give me a minute. I'm just restarting that software. Just a moment. Okay, so we're back online with that. So the final thing now is parallelogram law. This is a combined theorem for the sum of two vectors and the difference of two vectors. Both the things are within the same diagram and the same theorem. So actually this is nothing new. It just comes by combining the two triangles. Okay. So what happens is, given a vector A and given another vector B, and the angle theta between them, let us just quickly draw the sum and difference triangles first. So the sum wala triangle looks like this. So this is the resultant sum of A and B. This angle we generally call alpha. Here this exterior angle is theta. And for the difference of the two vectors, we draw the vectors this way. The vector E plus of the vector minus of B. So minus of B becomes like this. Just now what we did. So instead of adding A and B, we are adding the vector E with the vector minus B. And there this interior angle is theta because we are adding minus B. So this angle is 180 minus theta, like that. And in that diagram, the difference of the two vectors is nothing but this third side of the triangle. So this now represents A minus B. It represents this. Okay. Now think what would happen if we just combine these two diagrams in one. So we'll get a parallelogram. So I'll explain how we get a parallelogram. So next what you do is, you take the original two vectors A and B, but you draw them from a common origin. Instead of drawing them head to tail or back and forth like that, it's like, instead of thinking of them like displacements happening one after the other, think of them like forces which are simultaneously acting at a point. So that becomes your common origin point, and from that, both the vectors are drawn sourced at the same point. So here, this angle is theta, and these sides are A and B. Okay, so step one, okay, draw the vectors A and B from a common origin. Okay, so unlike the triangle law, where you add them head to tail like this, okay, you draw both these vectors, you pick up both these vectors, but draw them from the common origin point. Okay, so that's your step one. Now, next step, what you do is you draw some additional guidelines, like let's say this one, to complete a parallelogram. So draw two additional parallel sides to complete a parallelogram. Let me just. So these are like guidelines. Okay, so they are. Okay. So that's our step two now. Draw two parallel sides to complete the vector parallelogram. So vector parallelogram is a parallelogram with adjacent sides, that means non-parallel sides, as the vectors A and B. So that is now the parallelogram that you got in your figure. So this is the same as actually this side B, and this A is the same as this side A. So two parallel sides are A and two parallel sides are B. So you got your parallelogram by constructing this. Now third step is self-explanatory. Now you can see that in this parallelogram, if I draw this diagonal from the origin to this side, okay, now you can see that if you just look at this shape with respect to this, you will realize this triangle A plus B this one is the same as the triangle that you have above. So that means this diagonal is becoming which one? It is just becoming the sum. And this angle is alpha. So this is what we call the primary diagonal, because it is from the origin to the opposite side, and that becomes the sum. So you can see that this triangle, this one over here, is the same as actually the A plus B triangle. You consider these two sides, this one and this one, where this angle is theta again. So that triangle is contained over here. This is A plus B. So one of the diagonals of your parallelogram, and that one is called the primary diagonal, actually forms the sum. Now similarly, if you draw the second diagonal, which is this one, from the head of B to the head of A, so you can say from the tip of B to the tip of A. Instead of from common origin, it is head to head, that one. So you can see that that diagonal now represents E minus B. Because this triangle, just follow my cursor. So this triangle that I'm showing over here, this triangle is the same as the vector difference triangle above here. This triangle is the same as that second triangle involving this one. Okay. So that particular triangle is this one. You can see that if this was a vector E, this would have been the vector minus B, and this triangle is that one. So this red colored vector here is nothing but E minus B. So the advantage of this method is that now within the same diagram, by drawing a parallelogram using the two sides A and B, I've been able to show the sum and the difference within the same figure. So what was my step one in the construction of this parallelogram? My step one was that you first just draw the two given vectors A and B from a common origin. That's it. Second step was now draw two supporting parallel lines. So A ke parallel yahan pe ek line, B ke parallel yahan pe ek line, and that completes your parallelogram. Now the third step is within that parallelogram, you will be able to see both the sum and difference, and that is this. So I'm just writing down the third step. Okay. The primary diagonal that is from the common origin to opposite side, to opposite vertex, that becomes the sum. The primary diagonal actually represents the sum of the two vectors, and the secondary diagonal which we have drawn from tip of B to tip of E, this one, from tip of B to tip of E, that actually now represents, so this secondary diagonal now represents the difference, E minus B. Okay. Now in terms of algebraic formula, it is the same as what we've seen in your triangle law. So the magnitude of this diagonal A plus B is just given by that same formula, root of A square plus B square plus 2AB cos theta. So as I said, it's nothing different. It's just that we have combined the two triangles. Whereas the magnitude of the other diagonal, the difference one, is given by this formula, root of A square plus B square minus 2AB cos theta. Similarly, here tan alpha is B sin theta upon A plus B cos theta. Whereas there, tan theta becomes B sin theta upon A minus B cos theta. So these formulae are exactly the same as what we have seen in the individual triangle law of part A and part B. And that's not surprising because actually you're getting this parallelogram by combining these two. But as more and more we start doing analytical questions, where within the same question we are comparing, let's say, the sum and difference of two vectors. So there it might be useful for us to be able to geometrically understand in the same shape or in the same geometrical figure, where is the sum, where is the difference, so what is the relationship between them. So that is where your parallelogram law of vector addition or vector subtraction, both combined in one, becomes a very useful tool. So we'll discuss more about its application in the next lecture. But you can, plus I'll be giving you a worksheet 4, which will have certain questions which you can solve using this. But the main thing is just go through the derivations of these additional theorems that we've discussed today in the last part, the geometrical application, and do a thorough revision of component algebra and complete worksheet 3. That's your first task, of course. Complete worksheet 3. Any difficulties you're having, resolve that with me. Then you do a revision of all these things, particularly the parallelogram law and these theorems, and then you can start on worksheet 4, which you will get in a day or so, and you can start working on that. Okay, so that's it from me for today, guys, and hope you've understood this session properly and you're doing all right. Okay, so keep up the hard work and keep your motivation up in your studies, though it's a difficult time for all of us, and seek my help wherever you need anything, wherever you're having any difficulty. And that's it until the next lecture or mentoring session. All right, guys. So as always, stay safe.